Welcome everyone to another Silicon Labs product podcast. How many of you have ever gotten frustrated changing dead batteries from a device in your house? I think we've all been there before. Well, that leads us to today's topic of this episode, energy harvesting. Specifically, how companies are working today to design wireless light switches that leverage the energy harvested by the movement of the mechanical switch. To provide us great insight on this topic, we are joined by Santoshi and Amdam. Santoshi Kathapali is the product manager at Silicon Labs for IoT end devices that include these types of devices like smart switches. And Amdam Gade is an applications engineer at Aero Electronics, and he leads a team that helped develop this reference design for the energy harvesting switch we're going to be talking about today. Thanks both of you for joining me today.
Thanks for having me.
Thanks, Kyle, for the introduction. Thank you.
Sure. Well, for our listeners, I wanted to draw the attention. I was really impressed with the research and the design that both of you guys did for our recent WorksWith event. Your course on how to build this energy harvesting switch was really well done.
Thank you. It was great to be there. It was really fun to put together, and overall, it was a great project to work on.
Yeah, same here. Thank you, Kyle.
Well, our listeners can catch the full 60-minute course that you guys recorded by clicking the link. I put it in the details for this podcast below. However, I think that they'll benefit from us talking about a few questions today. So are you guys ready to get started?
Absolutely.
Let's get to it.
All right. Well, Santoshi, let's start with you. Can you share with the audience the shift, the things that you talked about for the opportunities in the energy harvesting space? And what do you see driving this growth?
Yeah, sure, Kyle. There are a number of key factors which are actually driving this growth in the energy harvesting market. First, if we speak in terms of numbers, currently the market potential for energy harvesting solution is around 485 million USD dollars, and it is projected to grow to 775 million USD dollars by 2025 at a CAGR of 9.8%. And the key factors fueling this growth are extensive implementation of IoT in building and home automation. So when I say home automation, there are a number of IoT devices that we use, like switches, smart locks, cameras, sensors, light bulbs, etc. And all these devices require low power and low energy devices. And that's where the energy harvesting comes into play. The second factor fueling the growth is the rising adoption of wireless sensor and wireless mesh networks equipped with energy harvesting system. And the third factor is the growing demand for safe, power efficient, and durable systems that require minimum or no maintenance. So if you ask me, these are the key factors that are fueling the growth for the energy harvesting solutions.
Well, I can vouch for many of those. I've been adding wireless technology to my house, and I know that I could use some of those advantages. But I think I'm going to probably be contributing to that $770 million of growth. So, Amdam, what did you find was the most difficult part of the design that you're going to be talking about when you put it all together? Maybe before you do that, why don't you give a quick overview of what it is that you did build and what that biggest pain was?
Yeah. Okay. So we were tasked with creating an energy harvesting light switch. Now, the end goal, of course, is to turn on a light without running a wire between the switch and the light fixture, all while powering the system using an energy harvesting generator as the primary source of power. So the goal of this design was to showcase the Zigbee green power capabilities of the new Mighty Gecko 22. One of the roadblocks that we had to overcome was at the time of our design, the SoC was not yet available. So we had to use the radio board. In this case, we used the BRD 4182 radio board. But one of the struggles or roadblocks we had to overcome was that this increased the power budget of our design. So let me give you a brief outline of our design. And I'll start with the energy harvesting element. We utilized a monostable energy harvesting switch made by ZF. This switch generates energy when pushed down, as well as when released. Therefore, it outputs an AC voltage, which goes both above and below ground. So this is not useful for electronics, so we had to rectify it through a diode to make a positive voltage. And then we fed this energy into a capacitor or an energy buffer to make the entire voltage waveform positive. For this radio, this is still not useful, so we must add a DC to DC converter or a buck converter, to take this varying input voltage and make a well-regulated 3.3 volts, for example, to power the radio. So for this component, we use the LTC3106 DC to DC converter with a low question current optimized for low power systems. If the primary source is unavailable, the energy harvesting solution is unavailable, the LTC3106 seamlessly switches back to the backup power source. So the LTC3106 is compatible with either a rechargeable or primary cell battery and can trickle charge a backup battery whenever this energy surplus is available. So this helps solve our issue with the high power budget and made our design backwards or forwards compatible. So meaning this reference design can potentially be used as a fully batteryless solution in the future. Now we can take the harvested energy created by the user's action of the light switch and turn on the light. So what we found tough was maintaining a very low energy budget without compromising on features such as security. So with this design, we've been able to create a robust, secure system that really takes advantage of energy harvesting and showcases the potential of the MG22.
Well, I mean, I saw the demo in the course. It's impressive. So, as I mentioned, I have put the details, the link to the course that you guys recorded. I'd encourage all of our listeners to watch that video, and they can actually see the demonstration of the switch that you did. Because, as you said, there are many things you overcame, and I'm sure that the engineers will find it valuable. Could you maybe talk about one or two things that engineers may find interesting that you've developed or that you solved?
Yeah, so one thing that maybe most people will not think of was the enclosure design, which was in itself quite a challenge. So in this case, the enclosure isn't only to house the boards, but also carries a functional use. So each time the button is pressed on the enclosure, the switch must be activated. So given that there are multiple buttons, we had to come up with an intuitive design, which I believe we've been able to do. Additionally, Scilabs allows for 5 different energy modes, each with their own benefits. Deciding the best for this design without compromising latency or power budget was quite the challenge. And in the end, we went with the EM4 shutoff mode, which is made for applications that don't need RTC or RAM retention.
Yeah, I mean, if taking a design down to the EM4 is not an easy task, so that those are very low energy levels, so that's pretty impressive. And the enclosure that you guys came up with was pretty slick looking. It's kind of like a Nest thermostat, but a really nice polished black. I thought it was impressive. So definitely, engineers should take a look at both that mechanical and the tricks you did to get it down into EM4. So Santoshi, what do you think will be the changes in the future that makes the types of devices that Amdam designed be more readily available, so that I can get one on, in my house, so I can use it with my wireless network?
So I think there are a few factors which would actually enable more adoption of energy harvesting solutions, and one of them is low energy devices. As I spoke earlier, the largest market of energy harvesting systems is for building and home automation. The key requirement to fuel the widespread adoption of home automation is low power devices. And energy harvesting is the best solution for low power wireless sensor networking and Internet of Things and smart building. So I think coming up with low power devices would be one of the key factors that would improve adoption. And the second factor would be integration of these devices with home ecosystems such as your Alexa or Google Nest. And the third factor and the key factor would be innovation. So innovation is another leading factor for widespread adoption of energy harvesting solution. And the market consists of big, small, and medium-sized enterprises, and they are focusing on introducing new products that are equipped with novel technology. So, for example, a multinational company recently blended their SOC with their energy harvesting PMIC. And what it would help them is in enabling IoT applications that would require ultra low power autonomous operations. So innovations like these would be another key factor that would drive the adoption of energy harvesting solutions.
Yeah, I mean, we work at Silicon Labs, and we see our engineering department every day pushing those bounds. So as they come up with lower energy devices, that's key. You see all the home automation ecosystems, with the announcement of Chip and other Sidewalk just came out. All these ecosystems to allow people to do more with their smart homes. I think it's going to really open the doors for people to develop these types of devices. Well, I do appreciate your guys' time. We're getting close to the end of our podcast, so I want to make sure Amdam that I give you a chance to share how can our listeners get access to the information for this reference design and what's involved?
Yeah, of course. So the easiest way and quickest way would be to visit our open Git repository, which will have all the information and the design files readily available for download for free. Here you'll find all the software files, the PCB design files, and all the enclosure design files. Additionally, they could reach out to me directly. My email should be attached to the PowerPoint recording. It's just amdam.gide@arrow.com. And then they could also reach out to our group, the Arrow Engineering Services Group, by simply emailing esc@arrow.com. We have a dedicated group of over 30 subject matter experts that can provide customers detailed support beyond just energy harvesting.
Well, that's great. And I know I would strongly encourage anyone with questions to reach out to you guys. You're a great group. You know more than just Silicon Labs. You work with several silicon semiconductor manufacturers. So, Arrow is an opportunity for someone who's evaluating multiple solutions to get a single source of information. So you guys will do a great job with that.
Appreciate it.
Well, thanks, Amdam and Santoshi. You guys did a great job. I think that this was a great episode and that our audience learned quite a bit about energy harvesting switches. I encourage you to look at the link and the details of this podcast and revisit the recording that Amdam and Santoshi did at our WorksWith event. It was not only informative with Santoshi's market research, but Amdam did a full 30-minute explanation of the design challenges, and he has a really great demonstration of the energy harvesting switch. So take advantage of that. So thanks again for both of you for joining me today.
Thank you, Kyle.
Thank you for having us. It was a lot of fun.
Sure. And thanks to our listeners for joining the podcast. We look forward to having you join us for future podcasts, and take care.